What's up, guys? So today we are covering steganography. If you guys don't know what that is, it's basically hiding information in plain sight. So what does that mean and what's it used for? That's really the big thing that everyone wants to know. I know some people may be familiar with it and have seen it, but don't understand really why it's used in the hacking world and why we use it fairly often. So number one, what it is really hiding, let's say, secret messages in images or in, other text files. Basically, you're taking bits that are wasted on files. So for instance, on an image file, right, every single pixel in that file is not being used, okay? So you can hide secret messages in them. That's why people use image files most often, is because every single bit in that is not being used. So it's hiding information inside of a file. Now, what's the point of this, and what's the difference between this and cryptography, right? So cryptography is actually taking a message and making it unreadable, okay? It's not hiding it. It's you can get the message and still not be able to read it. That's the whole point, right? Steganography is hiding it. So the difference is, if I get a hold of an image that's got steganography in it, theoretically I should be able to pull the data out myself and read it pretty easily without having to mess with it. Now, first thing we're going to need with steganography, we're going to need a text file, so our secret text. So secret payload, we'll say, okay? So while we're doing that, we want to go ahead and make a directory, and we'll make it steg, okay? And then we'll cd into that. We'll go ahead and save this. Now, this is our secret payload, right? So obviously it's not a real payload, but we're going to pretend it is. There's steg, and we're going to say secret, whoops. We're going to name it secret.text, okay? Perfect. So now that we got our secret payload. Now, what's the point of this, okay? So a big point of this is, number one, let's say you do get, in a pen test, you do get inside of a network, right? Well, 90% of the time, even though you're in there, they have protection devices in place. So if you start pulling social security numbers out or something like that, right, or credit card numbers, they have data protection that's going to notice that those files specifically are being touched, okay? So what's the best solution you can do? You can hide what you're pulling out so they cannot tell what you're pulling out, right? That's a big one. The other one is, so there's a lot of malware signature detection. What that means is it's going to look for the malware that you're sending. That's going to be known by these intrusion detections, intrusion prevention devices. They're going to know what that looks like based on the signature, okay? Based on the hash, based on what it does, that type of stuff. If you can hide that and get it into a computer, then extract it, then the firewall did not get to see it and didn't stop it, okay? So that's kind of what you're looking at using this for, partially. Another big one is, like, when Snowden, I'm not a fan of what happened, all that stuff. I'm not going to talk about what Snowden did, but what happened when he was pulling data out, he actually did it offline, but for instance, he could have hid the information before he took it off the computers, and it would have raised less alarms, right? Especially if he was going to send it off. But the computer intrusion detection device might be like, oh, they're just putting pictures on a flash drive, rather than, oh, he's putting a classified document on a flash drive. So keep that stuff in mind. My headset keeps clicking, so sorry about that if you guys can hear that. All right, so we've got our directory. We've got our secret message. Now we need to get a picture, right? Let's get a picture. I'm going to show you two different types of steganography, so we'll just say random picture. We'll go with this one. This is a goofy one, right? Save image, and we'll save it to right here, and we're going to name it picture.jpg. Perfect. So we've got our picture, we've got our secret text. Now what do we do, right? Well, first thing, we know the difference between cryptography and steganography now, right? Okay, so now what does steganography do? Steganography changes the bits of the message in a sense of it uses the spare bits. versus cryptography changes the bits. Now, that might not make sense to you guys right now, but basically, you'll see we're going to, first things first, we need to actually take the two messages we have, okay? And really the only one we care about is the picture one, but I want to show you guys both. So we'll do Md5 Sum, and we'll say picture.jpg. So this is our hash for the picture itself, okay? It's important to know this because as soon as we touch this file, as soon as we change one of the bits, even the spare bits, that hash is going to change completely. The reason that's important is that would stop a signature or a intrusion detection device that's looking for a hash on malware from seeing it, right? The other thing to notice is if someone ever sends you a file or something like that and it's supposed to be legit, if it's legit, then there should be a hash somewhere for it. And you should be able to check the hash for the file you've received and the file that is legit and see if they match up. If they match up, then no one's changed anything with it. So it's very, very, very important to know what hashes are and understand what they're used for. Now, okay, so we've got the file, we've got the hash, we're good with that. Now we're gonna check the hash of the secret.txt just to make sure that it's not gonna be, we're not just exchanging hashes, if that makes sense. So you can see, completely different, perfect. So those are the two files, that's awesome. Okay, so now one more thing I'm gonna check is the size of them. So you see picture is 7188 and secret is 15. Secret won't matter, but you'll see what's going to be some indicators if you're looking for steganography or if you're looking for hidden stuff. So if you know this picture, like let's say you have this picture on your computer and you know it, right? You know it's 7188 is the size every time, and then one day you hop on and it's more, that's kind of a red alarm. The other thing to check is if it's gaining size later on. There's a lot of ways to check this. If it's a picture off the internet that you see, you can check the size versus the one you received and see if it's a little different. But it's just good to notice that it does change the size, okay? Because that stuff is going to be all ways that they can figure out that it's being used in steganography. All right, so now we've got the sizes. We created the directory for it. Now we're going to use the steg hide. This is a tool that only works on JPEGs, unfortunately, but there is other tools out there, and I'm going to talk about them. But this is the tool that we're going to use for ease of use. So first thing we're going to do is steg hide, and this is just steg hide. We have to type first. We'll just type it with nothing, okay? And you can go through here, and you can see the embedding options. So we need to put embed, and then we need to put EF, and then CF for cover file, okay? So I'm going to do it the long way because I want you guys to be able to see it. So we'll go ahead and do steg hide, and then we'll go ahead and hit the embed on them, and then embed file. And this is the file that you're going to be embedding. So this is the file that's actually going into the picture, and that's our secret.txt. And then we're going to do the cover file. So cover file, and this is what is covering it, right? Which is our picture. So picture.jpg, okay? And then you don't have to do this, but I like to do this just in case. So we're going to put a password on it, and we're going to say password 123. And you don't have to put a password on it, right? It's almost counterintuitive. I know you guys can't see that. I'll show you here. All right. So the reason I put a password on it is simple. It's because let's just say this does fall into the wrong hands. Someone just does a quick thing on it and gets the information, right? We don't want to do that. So there's our actual command. We hit enter. All right, and you see it says done. So now we hit ls, and you notice the secret.txt is still there. That's important because you got your secret message in there. Once you verify that it's in there, we're going to remove the secret.txt. So now it's deleted. We don't have anything in there, right? That's important to see. So now we go ahead and we're going to check the Md5 sum of the picture. Okay, instantly I can tell it's different. So this starts with DBB, okay? And here it starts with 06A. So it's completely different. So if I was sending this to somebody, right, they would know instantly if they know what the legit files hash is, which is common. You should know what the legit files hash is when downloading a legit file. If you go to a legitimate website and they have downloads, you can usually get their hash on their website from them. So that verifies that nobody changed that file. So that's really important. The other thing to keep in mind, guys, is now this has a password on it. So even if someone intercepts it, theoretically, they can't break it. Now, there's ways to try to break it, obviously, but in my password's password123, so it's very easy to break. But the other thing to check is, sorry, I'm about to sneeze, is the size. Oh, man. Bless me. Bless me. All right. So now the size, you notice it's 7188 was the old size. 7702 is the new size. Now, let's pull up calculator here. So 7718. Or was that it? Did I say 7718? I don't know if that's right. 7188, excuse me. 7188 plus the 15. And you notice, if you see plus the 15, it's 7203, okay? But then on here, it's 7702. So it's not going to link or add up perfectly, right? Because you're embedding that in there, so it changes the size, but it's not going to add these two up and change perfectly. So keep that in mind. That doesn't mean that it's incorrect or anything. It's just going to change the size based on what it needs to do. So now we have one file left, or just one file. Now let's open that picture and see if we notice anything weird about it, right? So we'll go ahead. Here's our picture. All right. Did we notice anything weird? Is there any message in here? Is there anything that would stick out to us? I don't see anything. I don't know about you guys. No, I don't see it. Okay, that's good. That means it worked, all right? Now keep in mind, it's using the spare bits in this file. So theoretically, could you find it? Maybe, but you'd have to have an insane computer or insane software, excuse me. But that message is now written into that file, but it's in binary, right? It's using the binary bits. So let's go ahead and unshow the message now. So now we hid the message. All right, so now we check the hash and we check the size and we notice they're both different. So if I knew this file, I would detect it pretty quick. So now to actually get the message out, it's super simple. It's just steg hide. And then if you remember from up above, it's extract. And then SF is for the stego file. So whatever file you have steganography on. And we're going to use picture.jpg. And when you hit enter, it's going to ask for the password. Now, you can enter the password in the command, but we're not going to do that. So now, password, wrote extracted data. So now secret.txt is there. So cat secret.txt. And there's our secret payload. Now, let's say I just got into your network and you hold all kinds of social security numbers, right? And I put a list of all the social security numbers off your network into a file, into a picture file, hid it, and then pulled it off your network. Well, let's say you then figure out that some of your social security numbers are leaked, and you're looking at how you did it, and you're looking at logs. The logs you're going to see coming out of the network is just someone took a picture file. You're not going to see that somebody took a bunch of social security numbers or a bunch of your lists of social security numbers. So keep that in mind. That's important to realize. That's a big reason why steganography exists, because it's a way to get information in and out of a network without the firewall looking for specific signatures. All right, so now here's another question for us. Let's say we do that again. Okay, so big thing here. We'll hit no. We'll go ahead and remove that secret.txt file, and we'll do it again. All right, and you notice it pulled it again. So why is this important to us, right? Because that image file still contains those secrets. Even though we pulled them off, it still contains them. So it's important to know if these are sensitive information that you're trying to keep, you need to delete that file, okay? Because that file now holds that information. All right, So now we've got steganography down as far as for steghide. We're going to keep using this directory, and we're going to use that same image just because we can. And we're going to use a tool called Exif Tool. If you're not familiar with this, it's going to pull metadata. If you aren't familiar with metadata, every file you touch has metadata, meaning it knows when it was created, knows when it was edited, it has author information, all kinds of metadata, where it's located, all that stuff. So now we're going to check the Md5 Sum again, and we're going to do image or picture, whatever I named it. All right, so now we know that the Md5 Sum, that's important. And then we're going to use the Exif tool to try and find, so Exif Tool and then picture.jpg. And if you notice, all right, so we've got some information, that's good. But where the key comes in is we can actually insert information. Okay? So we can say Exif Tool, and let's say the author right now, let's say this is a piece of malware that we're using, but it shows that I created it. Let's say it says author and I created it, right? I don't want them, if they find the file, to be like, oh, Stuffy created this. No, we can't have that because we'll get caught, right? So one thing we're going to do is we just do Exif Tool and we say author, right? And then equals, and we'll just say it wasn't me, it was, I don't even know, let's say Network Chuck because I like him. This is a shout out to Network Chuck, right? So let's say it was him, and then we just do the picture.jpg. Okay, so now it says file updated. So now if we go back and look at it, you notice the author now says Network Chuck. So that'll at least take a little bit of heat off of us, right? Because now there's more things they can do, but that's one thing we can do with this. That's really nice because we can cover our tracks a little bit. Let's say the file modification date. Let's say they notice that this file was modified when it shouldn't have been. We can change that date if we wanted to and change it to a different date, 2 years ago. And then they'll be like, oh, no one's touched that file in 2 years, right? Stuff like that. Now, here's where it can get really handy too. Let's say I want to get some malicious code in, but every time I try, the firewall stops any sort of text format coming through with code in it because it's noticing what's going on, even if I'm breaking it up or if I'm doing fragmentation, even then. So let's say I send you a bunch of pictures in a zip file or something like that, right? So, but the pictures you're thinking, well, these are weird, they're just pictures. But let's say I have someone on the inside or I have access to a network on the inside, I just can't get that freaking payload in there. Well, what I can do is I can use that Exif tool, and instead of the author, I can say comment equals, and we'll say this is where our secret payload goes, and we can combine all the photos. All right, and then we hit enter, and then we hit the Exif tool, and you notice there's a comment here. This is where our secret payload goes, and we can combine all the photos. Now, there's a couple of things here. Number one, if you wrote the payload yourself, typically you could just rewrite it on their network, right? But if it has certain things in it that you need, if it's already compiled, that type of stuff, and they don't have that type of structure on their network that you can use, you can do it this way. So what I mean by that is, let's say I send you 50 photos and all of them have a couple of lines of the code. I get there and I just pull all that code out, and boom, I can now run that as one single file. Now, this is just a rare example. I don't know how often you're going to be using this specific tool for that, but it's an example of where it can come in handy. The main big thing that I use this for is hiding my tracks, right? If I pull a file in, I want to hide this information. I don't want them to have my author name. I don't want them to have the date it was modified, because that's a red flag right there. If it was modified yesterday and we had an intrusion yesterday, it's pretty obvious what just happened, right? So that type of stuff, you need to understand what you're changing. But this doesn't change the file at all. The only thing it does change, and this is where, again, if you are familiar with hashes, you're going to figure it out. The hash changes every single time you change even the metadata, because it's still part of the file. So it's important to know what you're changing and understand if you have the original hash, then they're gonna detect that the file changed. But that is steganography, guys. This is a fun basically tool that you can use, a couple of tools, but it's a fun lab that you can do on your own. I just built this lab real fast. I've done some steganography in the past, and so I thought this is an easy one for people to do. I do have my notes. They will be in the Patreon. So if you guys are enjoying this and want access to the notes kind of break down the commands, and then also we'll give you a little bit more information, some of the different tools you can use. And then also it just has little snippets like I have in here. Spectrogram, steganography is also an option. If you're not familiar with spectrogram, steganography, it's simply just audio files doing that. So basically, the notes have a little bit more information than what I cover, and they also allow you to read it as you're going or do the lab yourself because it's a walkthrough with my labs. So hopefully you guys liked it. Hopefully you guys have fun with steganography because it's really fun to do with your friends. You can send messages back and forth. You can do all kinds of stuff to hide it. Let me know what you guys think, and if you guys enjoyed it, go ahead and like and subscribe, and thanks, guys.